beginning here, right?
Oh yeah. Yep, we'll start at the beginning.
Where does the ram air turbine drop down?
Ram air turbine will drop down right, oh, there, right? If I could crawl over and point at it, I would, but you can kind of basically see where the panel comes out. Right.
Oh, that's it.
Yep.
Oh, it's small.
Yeah, yeah, it's tiny.
Oh.
Think about the best way to describe a ram air turbine is it's the size of a large model airplane propeller. That's all it is, and it's just going to spin, and that's why it doesn't produce high voltage, because if you get in that situation where you have to deploy your rat, you need to start thinking about somewhere to go rather than your destination. And that's part of that, is they want to, what that does is it not only does it drop and give you that, but it also helps, in pilots' minds, put that sense of urgency in us. Because to pilots, we're invincible, and we can do it. So,
at what point do you have to deploy the rat?
Your rat will auto deploy. Yep.
How many generators?
It's going to vary from airplane to airplane, but you typically, if you lose all 4 generators, and your engines are gone. Sometimes it might deploy at a loss of 2 to 3 generators, but the logic is built in. You do have an option to deploy if you have to, but you don't want,
So you can lose one and nothing.
Yep.
Basically on captain's instruments and a few engine instruments.
You're on your standby. You're on your standby. So your panels will shed, and you're gonna go to your standby gauges. All right. So what we can do is we'll start right here. We'll move this way, around, and then go up in the airplane. We'll kind of do the backwards of what your diagram in your package shows. But this is a good place to start. So we're gonna start here at the wing. We have your ECS inlets that we talked about for your cabin air. The reason we have these is it's an all-electric airplane. Unlike previous generation airplanes, we are not pulling pneumatic air off the engines. Helps with the efficiency of the engine, helps reduce weight. So you get your fresh air that comes in here, you have your heat exchanger up there. All that helps filter, goes into your cabin, gets that fresh air in there. You have your HEPA filters, so you don't get the gaseous smells or things like that. It keeps that air fresher and cleaner. Now, as we're staring at this fuselage, we know it's an all composite fuselage, single barrel construction. So rather than panelized, where we have panel longitudinal joints, it's all single barrel, all built together. So basically, on this door, as we come around this airplane, if you go door 2 forward, that's all one big section, built by Spirit out in Wichita. Now, as we're staring at this still, let's think about this. One big piece of this airplane was the partnerships in it. The manufacturing partners. We have manufacturing partners in North America, Europe, Asia, and Australia. So it's very much a globally built airplane. And that to me, that is always a real key to stress with people, is that it's a global partnership on this airplane. We're using partners some partners we own around the country, like Boeing, South Carolina, and some that we don't own. So that kind of sums this up. As we move around, we'll talk about this individual pieces. Now, let's move to the wing, then we'll move down to the engine here. As we said, as we were walking here, the length of the wingspan is 197 feet long. High aspect ratio, very thin. That thinness is, we're able to be thin like that because of the composite structure. And it also is lightweight and very, very efficient, super efficient. The one really, really cool thing about this airplane is that flex. Airplanes are like birds, or as you take off, you see that wing flex. It's one of the most beautiful sights you'll see as a 787 lifts off the ground and that load hits the wings and just flexes up. One I always like to compare it to, just because I have the experience with this airplane, is the Embraer airplane. That wing is rigid. It does not flex. you hit turbulence in an Embraer, you're going to feel every single bump of that turbulence. Well, on the 8.7, we do have smooth ride technology, so we'll auto adjust using that up there. Doesn't get rid of the bumps, but it just helps dampen the oscillations. And then you have load alleviation, which we'll talk about as we come around here. So that's a nice quick overview of this wing that we'll talk about each piece as we move around. Now when we get to this Rolls-Royce engine here, it's a dual supply engine. You have a choice of a GE NX engine or a Rolls-Royce Trent 1000. Both are offerable on all models of the 8.7, customer's choice. Roughly 68,000 pounds thrust up to 76,000 pounds of thrust, depending on which model of the 8.7 they're going to. Really innovative parts on this 8.7 nacelle here. Laminar flow helps keep that wind close, so you don't get that turbulence coming off it. Helps reduce the drag, more efficiency. Then on the back end, chevrons. Helps oscillate that noise, keeps that noise down, makes the aft end of the 8.7 for the passengers quieter. Along with the cabin noise being quieter, the 8.7 also has a 60% smaller noise footprint than its competitor airplanes, future and previous generation airplanes. So community noise is reduced and cabin noise is reduced. One thing a lot of people ask is, well, how does all this noise happen? Because the way jet engines work is kind of confusing to a lot of people. You know, you suck all this air in, you compress it down, you light it on fire and make it go boom, and then you push out the hot air out the back, causes the plane to go forward. Well, that's not really where all that noise is coming from. That noise is coming from the hot air mixing with the cold air. So how do we keep that down? We have a high bypass ratio, 10:1. It also helps with the fuel efficiency. So 10 particles of air go around for every 1 particle of air that goes through the core. Any questions so far?
What was those ratios again?
10:1.
10:1?
Yes.
So you got laminar flow here. Does if I'm in a 777, I don't have laminar flow, or it?
So you have natural laminar flow coming on here. 777 does not. 777X will. The new 777X coming out will have a natural laminar flow engine, or nacelle, I'm sorry.
Okay, and that's covered by the design here.
That's covered by the design. Now, the really cool part about this nacelle is it's patented by Boeing.
Wow.
So, we all have heard of the new Airbus A330neo coming out. It's going to have a Rolls-Royce engine. Trent 7000, they're taking our engine, adding some stuff to it, and throwing it on an Airbus A330. But they can't have the same nacelle technology. That's ours. So they have to go out and develop a brand new nacelle for this engine.
This technology, is that distance here or the shape?
It's the shape, it's the distance, it's the angles, it's all of that that goes into that.
For the mic
Oh.
so that on camera we can.
Yep, absolutely.
Yeah, maybe one thing I want to add is the fact that the engines are actually interchangeable. So if you have a customer and they want to change, say, from Rolls-Royce to GE, they can actually interchange the engines, which is really a first in our industry.
So the pylon attach points are the same?
Pylon attach points are the same. Excellent. Yes?
Laminar flow. Shouldn't there be thousands, millions of holes in this?
That would be hybrid laminar flow. This is natural laminar flow.
Okay, I'm
So,
sorry.
yep.
I was looking for them. I know you can't see them.
Now, the hybrid laminar flow that you're referencing isn't on the 878 that we're looking at right here. That will be on the 787-9 and 787-10. And that is the one that has the thousands of little holes in it.
Yes.
Yep.
Okay, I was just curious.
All right, let's move right along here. All right, so
Helicopter's trying to land on me.
I love standing and staring in front of this engine.
Yeah.
Because one really cool thing about this, when you have visitors come out, the diameter of this engine is bigger than the diameter of the Concorde, the airplane.
In the Concorde.
Yeah.
Is there an engine in there? They left
There is an engine in there, yeah.
I was wondering where your counterbalances were. 'Cause the
Yep.
other day I was here, someone said you could look right through it. The engine's about the size of a,
Yep. So if you stand here, and I'm not sure where you guys will be located on the ones, because I know you're working on a glass top and all that over there. But what's really cool is if you encourage your guests, your visitors, to look at this and then go look at the Concorde, this is bigger than the Concorde. Pretty interesting. Now, we talked about two engine manufacturers, Rolls-Royce and GE. Obviously, this one's all Rolls-Royce here. They have the titanium fan blades. GE has the composite fan blades. Rolls-Royce and GE have decided to put their technology in different parts of the engine, but they're both producing amazing fuel efficiency. You put the Trent 1000 on the 87, you put the GE NX 1000 on the 87, you get a 20% fuel use reduction over previous generation airplanes. 20%. And let's say today's airplane fuel is $3.50 a gallon, 20%, that's millions of dollars. And that's why we've seen such a rapid acceptance of the 87.
We actually this week had Air Canada go public with that the savings that they're getting on the airplane is 28%.
And these engines are interfaced, right?
Yep.
And they can just change a Rolls-Royce to
You can change Rolls-Royce, you can change it to that. I mean, it's not it's not as simple as rotating your tires on your car, but it's a lot simpler than previous generation airplanes,
They have to change the whole infrastructure.
where you really couldn't even do it because
That's right.
the
It'll
cost
take
effective,
days,
you have
it
to.
takes 2 hours or whatever.
This will actually, it'll take a couple maintenance shifts to do,
Oh, really? Okay.
but it's not so much that, it's the cost of doing it as well. Because if you tried to go from a GE to a Trent on a previous generation, you're having to run new wire hosing, you're having to run new piping, you're having to do pylons. It was to the point where lessors said it was inconceivable to even think about doing that. But this gave them an option. It's really that secondary market this helps enable. Comes off a 10-year, 15-year lease. Someone else wants it, but they don't want to now stock spares on Rolls-Royce. They want to do a lifelong lease or buy it off of a lessor, they can do that. But at the same time, if they don't want to change engines, we have a great CAS program to help them manage their spares. Had to throw that plug in there. So remember, as we talked, no pneumatics, electrically powered, electrically driven airplane.
So what's this thing sticking out here?
You know, I would love to tell you, but I honestly do not know. A vent. There we go. It's a vent. So as we come up on this wing, we have anti-ice systems on here. And I stress anti-ice instead of de-ice. De-ice, pneumatic boots. Anti-ice helps prevent ice from even beginning to form. So on most airplanes, you have your ice indications. Once it detects that ice is building up, kicks on the anti-ice, causes it to whatever's accreted on there dissipate. The 87 can actually go one step further and detect those icing conditions ahead of time and kick it on if it needs to, so then you don't have to worry about that. One of the pilot's biggest concerns always is dealing with icing. It doesn't matter if it's boots or if it's electrically driven or if it's pneumatic, it's just dealing with icing, because icing can dramatically affect the performance of any airplane. 87 helps handle that because it's detecting those conditions ahead of time before we get to them. So that helps the plane, it helps the pilot, it helps everybody manage the flight path a lot better. So we have any questions on this leading edge?
Is it just a leading edge flap or trigger flap, or is it the same thing all the way through? Or?
Same thing all the way through.
Okay.
Yep.
And I was going to ask you about the flaperon thing. That's the back
Yep.
part of the wing.
No, go ahead. It's a perfect view right here.
It's basically an inboard aileron.
Yep.
Right? So that's just autopilot kind of driven?
Airplane drives it.
Okay.
This airplane is so intuitive. It's funny because I go and I fly these E-cabs over at the Duwamish down here, and you get in it and the plane's doing what you're thinking about before you think about it. I'm like, oh, I need to do that. Well, the plane already did it. Well, I should start my descent soon. Oh, well, the plane's already telling me when to do that descent. So it's unbelievable, the technology that is in this airplane. It's absolutely incredible. It has taken flying to the next level. We're mixing extreme engineering, taking the smartest engineers in the world, taking the most amazing programmers, and giving a pilot's dream right here. And a passenger's dream. We're gonna talk about the passenger's dream. It will awe you until you can't say awe anymore. So.
Can I ask you about the noise chevron?
Yes.
Is this designed for one engine speed only, or is it designed?
It's designed for all ranges, the whole gauntlet of the range. So the question was about the noise, the chevrons, and how were they designed for takeoff or high thrust settings instead of low thrust settings. It's actually designed for it all. It helps reduce the noise. It also helps reduce the weight. Now, you know, we're going to have those on the 737 MAX as well. That technology is just unbelievable what that did. And we found other uses for it. So, as Boeing partnered with NASA is how those chevrons came out. Little factor that a lot of people don't realize is our partnership with NASA helps with a lot of this technology that's going on to these unbelievable machines out there. So, anybody notice something that's missing on this wingtip that we see on 37s or some 47s? Winglets, blended winglet. Get this question a lot. Why does it not have a winglet? We hear about winglets. We hear about how efficient they are. It's almost as efficient as if you just laid that winglet flat and you get that efficiency out of there. On the MAX, we have the new advanced winglet coming off the bottom as well. People go, well, why don't you have this on the 87? Well, there's a couple reasons. One, Boeing's engineering and technology has found that a raked wingtip is more efficient on a large twin-aisle airplane than a blended winglet. It also reduces weight. The other nice part about it is you're getting all that efficiency and you can operate in gate-constrained areas. So if you have a tight box around your gate, you don't have this really long wing out there. Kind of goes back to that 777X as well as to why we're doing some of the technology on there. But yeah, the blended wing, the raked wingtip increases efficiency, reduces weight, more so than if we would put a blended winglet on this airplane. And we actually showed, when we launched this, we put a 4.7 with the blended winglet and a 4.7 with raked wingtip and showed the efficiency of the raked wingtip.
So this bottom winglet that's been added to Alaska planes,
Yep.
that increases the efficiency?
Yes, sir. Reduces your fuel use, increases efficiency.
If this raked wing is an improvement, are other airplanes expected to adopt that too?
Well, so the first raked wing, the question was, is the raked wingtip, if it's an improvement, are other airplanes adopting it? The answer is absolutely. We put it on the 47-8. We're seeing it on the 777X. People have found the efficiency of this design.
How about trailing vortexes? Are there less vortexes with this wingtip?
Yes, that's part of the efficiency because you have all that drag that comes off of there. It helps reduce your wake vortices. So now you don't have the separation issues on approach. For example, the A380, you put an 8.7 behind an A380, you're still going to have 3 miles separation because of the significant wake vortexes that come off of that.
The pipe device that comes out between the two.
Yep.
That's the purpose of that is
fuel dump?
Yes.
that's dump.
Yep.
Dump tube.
Yep.
Fuel dump. And you figure 1% of the weight of the aircraft per minute?
Yeah, about 1% exactly. So when you're doing the fuel dump, about 1%. So the question was on the fuel dump, about 1% of the aircraft weight per minute is what you can jettison out of it. All right.
Do airliners have a center fuel tank in the fuselage?
Yes. Yes. They'll have a center tank in there. So as we're standing here at the wingtip, and we look up at it, look at that swoop right now, there's no load being put on this wing. Coming from the wing root all the way out to the wingtip. That's just absolute, from somebody who loves airplanes, to me, that is just absolutely incredible that we're doing that.
How was the flexibility distance compared to other planes like the B-47 had a lot of?
So I'll be honest, I can't remember the exact flexibility of the wings, but this 787 has the most flex of any commercial airplane out there in its wing. Yeah.
And I can assure you, if you go to YouTube,
you can see the
there's
video.
going to be a lot of videos just of the airplane taking off, and you'll see the wings, and it's just amazing.
But the wing flex is unbelievable on this. One of the great shots that occurred was during the 787-9 first flight, and they put a camera on the runway as it lifted up, and then the camera turned and you could see the load that just took off. And that's all over YouTube. If you didn't have the opportunity to see it live, the views that they put that camera out there when they did that first flight captured that wing. It was unbelievable. I probably watched it a dozen times just because you sit and you watch how this thing, it just looks like a bird getting ready to take off. If you just sit out and you watch how birds take off and the wings come up and the load kicks on their wings, it's just the most gorgeous thing to ever watch. So as we come across to here, we notice these fairings, these tracks are really short. If you go and you look at any of the airplanes over there, you go and you find a 6.7 or a 2.7 or a 5.7, those things are a lot larger. Well, we don't need it as big anymore. It's a more efficient wing, more efficient flaps. Reduces weight. That's what that's all about. The efficiency, and I keep stressing efficiency, because I like telling that's the story of this airplane. Not only the cutting edge design, but the efficiency that came out of this design.
After this is the 800, right?
Dash 8.
Dash 8.
Yep.
Dash 9. Are they going to do anything after the Dash 10? Can they stretch this any further?
Dash 10 will be where we are. After that, we've got some great 777s for people.
How long before a freighter appears, you think?
That's going to be a while out.
Does that replace 767?
Yeah, and right now the 767 is such a hot demand freighter that the freighter market's undergoing some changes in itself. A lot of belly spaces out there now. So every freighter company, every airline, every manufacturer's seriously looking at, okay, what is that next freighter that needs to come out?
Right.
Do we need big? Do we need small? Do we need freighters? That's always the question now. We're always going to need dedicated freighters, but at what size and at what stage lengths and at what volumes do we need them? So there are studies going on, but it's going to be a while out there. So if we move down to the wheels over here, want to spend a little bit of time down here. So these are electric brakes. More efficient, better braking, lighter weight. Hamza, you know a little bit about down here, so why don't you?
Yeah. So one of the things that the brakes are really revolutionary on the 87 is the fact that I'm sure many of you, I think we have a pilot here. One of the challenges airlines have is wheel styles and brakes. With this brake system, you're actually able to disable, in case you have a brake failure, because it's an electric brake and a new design, you can actually quickly disconnect the brake and get it fixed as opposed to the older airplanes. And because of that, it's such a really good enhancement from an operational standpoint for the airlines. And the market has really adopted this, and they really feel that this has been very helpful for them. And the other thing that also is really interesting with the brake system is that you can actually, because of the new.
You need to speak up through it.
All right, can you hear me? Yeah. Because of the new brake system, oh, you can. Fine. Okay. Yeah. Because of the new brake system, it's actually easy for the airlines to, like I said, in case one of the brake system is not operational, they can easily MMEL it and they have a better dispatch. You can easily dispatch with an inoperative brake as opposed to the previous models of airplanes.
The one thing, another really nice aspect of this is brake wear. It through the computer systems, it relays its wear indication. So if we take off and the wear indication is coming down, they can track that. So when they land and they get to the gate and they need to change the brakes out, they can do it quicker and not take a delay on it. Back on a lot of older airplanes, the
747, the main gear, they can steer part of it?
Yes.
Does this have
No.
that capability? So they're just dragging rubber off the tires?
Yep.
Okay.
On older generation airplanes, when the pilots do the walkarounds, you have to crawl under and you have to check your brake wear indicators. It's a little stick that comes out. And if it's too wore down, you have to get them changed because you can't go. You take a delay. The average brake will take 30 to 45 minutes to change out. Average turn times 45 minutes to an hour. So you can kind of see how that delay backs up. The 87 through its systems can relay that brake shouldn't have to get changed before the airplane's even on the ground. Maintenance can be there to meet you at it. So that's really a really big advantage to it. It also, the 87 has better anti-skid protection and what we call touchdown protection. Or on the flight line, we call it first officer protection, because they like to try to land with the brakes on, and that way you don't skid you don't spot your tires.
And for our operators who run this airplane, like in Japan, where they actually run this like a 3.7 with 6-8 cycles a day, the fact that you can easily do the quick disconnect is such a big help for them operationally. So that, like Aaron said, if they know that the brake system is failing, they can within the 45-minute turnaround, they can easily do a disconnect and repair it, which is really important for them.
I'm sorry?
Regenerative braking?
Yes.
And do they spin them up before they hit the runway?
Yes. Basically all new generation airplanes are doing that. You could go all the way back to 2002 manufactured airplanes, and they're doing that. Because they've all learned that, a lot like NASCAR brakes on NASCAR race cars, you got to get them spun up and get them hot, and that helps extend the lifespan of them because it's the graphite brakes.
Why are the struts angled?
I'm sorry?
The struts are angled slightly?
Loads.
Loads.
Yep. Soft landing, trailing link, because so as you come in, you can always tell whether there's two ways to tell whether a plane has trailing link gear. Smoothness of the touchdown, and if your pilot flew a flat approach, instead of feeling like you just landed like that, it will absorb it a little bit more. All right, so back here on the tail section, one thing that a lot of people have asked is, why do we have that panel that's off of the actual fuselage of the airplane? That's because the whole horizontal stabilizer moves.
Why is the piece on the end titanium and nothing else is?
That's your APU exhaust.
Okay.
So with the amount of heat, exactly. So yes, that'll be why you have that titanium back there.
Does the horizontal stabilizer move for trim, or does it move as part of the
It moves
control
part as
system?
a load alleviation, and then you have your trim tabs on the back.
Okay.
Yep. So it'll move for takeoff, landing, and also you'll see it do that. Exactly. Yep. Nominal pitch control.
Batteries are in here somewhere?
Batteries are actually right down over there.
Batteries are there?
Yep.
Okay.
So it has the two. While we're back here, we'll talk about those EE bays. You have two electronic bays: a forward electronic bay and an aft electronic bay. Your forward electronic bay does your your aft electronic bay does your high output, and will send some of that up to your forward electronic bay.
So there's a separate set of batteries for backup for the controls.
Absolutely. Yep.
Right.
Your backup battery is a separate system. Then your battery's down.
That's close to the equipment.
It's further up front. Exactly.
Okay.
Yep.
APU's a backup also?
I'm sorry.
You can You can start the APU at emergency power.
So if you start losing, so the question was, can you start the APU for emergency power? So if you start losing generators, that's one of the first things that pilots do. They'll click on the APU, it's a generator. You can help power some stuff. Now you're not going to fly a long time on that because you've already lost one thing and you just don't want to keep going as that. So we talked about how this moves as a whole. We talked about why you have the aluminum piece titanium on the back. That's your APU exhaust. As we come around, and we've also answered the question why we don't, about how hybrid laminar flow is not on the tail of the airplane. So, anybody have any other questions back here before we? So the question was, some 777s, some 727s, and other airplanes have a tail skid. The 87-8 doesn't have a tail strike problem. The 87-10 has a tail skid on it and has tail strike protection. So as you know, we talked about the ailerons, flaperons, and so you know, we use the flaps on takeoff and landing because it extends that wing out, helps extend the lift, and helps you fly at a slower airspeed. Any guesses as to the flaperon back there? What we use that for?
You actually call that a flapper?
We call it a flaperon.
Load alleviation.
There you go. Load alleviation. There are some great videos on YouTube that you can actually see close-ups of it going into effect. Flaps obviously help with flying the slower airspeed when coming into land and help with the lift on taking off. Now,
Flaps automatic?
I'm sorry?
Flaps automatic or manual?
The flaps are manual. So when you look in the cockpit, you'll see that you have your flap levers and you still have to fix settings. Yep. No dial a flap on this airplane. So you have all that. Now, one question it comes up quite a bit at the public is, how fast do these planes land at? And the approach speeds are in the mid 150, 152, 155-ish. You don't, knots. You don't want to get it going too high because the faster you go, the higher your limitations on your landing are. You have to have better weather. So, because things just come at you faster. So that is a design philosophy of we want a fast airplane in cruise, but we want a slow airplane on landing. And you also help protect your wheel and brake usage by that.
What's normal takeoff speed?
You know, I would have to take a look at it, but
Depends on weight, I'm sure.
Depends on weight, absolutely. You know, your MTOs, goes all the way through MTO, OEW, runway contamination, atmospheric conditions. You throw all that in there.
The ailerons, the outboard ailerons operate all the time?
Yes.
In the 747, they're locked out.
They're locked out, yep.
Flaps are up.
Yep.
I just wondered if that's not the case.
Not the case here.
So both of these ailerons operate in flight?
They will both operate in flight. When you see the video that I was referencing earlier, once we load that up, you'll actually see it in movement. It's very small movements, but it's all part of it. It helps with that load alleviation there and that maneuverability.
What do you mean by load alleviation?
Load alleviation. So as you come into your turns, you're putting G's on the passengers and that. Those ailerons will do the small corrections to help alleviate and smooth it out. It's also part of that smooth ride technology. All that's playing together.
Need less bank
Less
in
ba-
order to turn?
There you go. That's part of it right there. Man, I love talking to people who know airplanes.
Do the spoilers work on top, work in conjunction with the ailerons?
Well, you're never going to want to deploy your spoiler in flight.
Okay.
Unless you're on descent. You know, if I'm in cruise and I deploy that spoiler, we've had a really bad day. So that your spoilers will help you on your descent. It'll give you that steeper descent angle, slow you down. You can get that steeper descent angle. Okay. But all of that plays together. It's all in that logic in the airplane.
Okay. Yeah, because I saw a video with it in flight.
Yep. Yeah. Those will be your speed brakes.
Yeah.
Help you slow down. So yep. Spoilers, speed brakes. Yep.
B-52, you need the spoilers.
Yep.
You don't have an aileron.
They're not used as roll control.
No, absolutely no. There was a lot of planes there. I forgot the name of the corporate airplane that was out there that used them as roll control. The MU, I want to say MU-52 or MU-2. I'm sorry. So the MU-2 uses spoiler-ons, but people have a hard time flying them because it is so dramatic when you do that. So, yep, you'll never see that up here. All right, I say we go inside this airplane and take a look in there.
Real engine?
It's a real engine. Yep. Real engine. Rolls-Royce donated it. So you got your AOA, you got your pitot tube, and then you have total air temperature. Total air temperature. Yep. These are your icing. These are the ones where it helps identify the icing conditions prior to getting into icing.
Always good.
Yep. Always great to have there.
Is the panel of the APU panel on the back of the nose gear, is that unique to the 787? I've never seen that on another aircraft.
I'm sorry, the which panel?
The APU panel on the back of the nose gear.
This right here?
Yeah, is that the panel on the back of the nose gear? Is that unique to the 787?
As far as I know, yes.
So that's a standard thing. It's not because this is a test airplane.
I believe that actually that is because it's a test airplane.
Okay, so that's part of the test.
Yep, yep.
Okay.
Yep, orange shape gives it away.
Yeah, but I think, like you said, other models do have the P40 to communicate if they're doing maintenance.
Right.
Yeah, with the guys that fly.
Yep. So as we go up, watch your step going into the cabin. But before we go up, I want everybody to think about something. As you walk in, imagine yourself walking down this jetway, crowded people everywhere, pushing, shoving, trying to get on the airplane. As you walk in, just kind of let your eyes move throughout the cabin. I love this experience, and it's what we call that cathedral effect. You go way back to the design of cathedrals back in medieval Europe and so forth. You walk through that tiny tunnel, tiny hallway, and then you walk out and it's a grand open space. That's what we did here.
Can I add something?
Yes, go right ahead.
So before that, actually, remember, you're going through security. You go through security. You go through the whole hustle. You know, you're trying to get through your bags. They're patting you. So that's the whole experience, right? And you go to the jetway. Okay?
All right, let's head on up. So this is what we call the full dome. Some have gone with half domes. The majority have gone with half domes because they want to put the monuments up here and maximum usage space. But full dome, you have your LED lighting up and down, full spectrum, so you can do the multiple different lighting scenes throughout. Comes with customized lighting, comes with standard lighting scenes, but they can be customized as well. But this is what we were trying to talk about, that cathedral effect. You walk through, you kind of get squeezed down at the door, and you come in, and even if they haven't gone with this architecture, you still get this unbelievable feeling when you walk in, especially if they have it lit up with the blue or whatever their colors are. It's incredible. So what we're going to do is we're going to walk down, we're going to go through this side, we'll come up past the flight deck, come back up here, go back towards what we call the dance floor area, and then out that back side. So while we're right here, are there any questions anybody has before we move?
Can you tell us about these? This looks like a changing table. What's this thing for?
Basically bars. This is just so obviously each airline can lay out their monuments how they want to, but we kind of just went with that bar style. So you could put your first class boarding drinks up here if you wanted to. You have your purser stations up there. So it's just kind of when we did this Dreamliner World Tour airplane, this is just what they chose to lay it out as. Qatar Airways has a system similar to that. It kind of looks like an alien pod because it's got a little oval right here, but the way they've lit it up and the way they light things up, it looks absolutely incredible when you walk in.
And this is the standard airline size for the entrance and exit.
Yep, this is standard airline size. The only difference is will have a monument right here. It won't be the full dome open. Yep, definitely separate them.
Speaking of changing tables, last week I had two separate women notice that there's a changing table symbol on the front restroom door.
Yep.
we couldn't look inside. There isn't one in the back. Is there actually a changing table in front?
That can be, that all of that is airline specific, customer to customer specific. So what they choose, they might put more amenities in your first class area than in your back, but it's customer to customer specific on that when you get to that level.
That would be the same with the business class, first class setup. And
Yep.
as far as
Now, majority of airplanes are being delivered, 87-8s are being delivered in two class, business class and economy class. But they're also going with the new economy comfort, premium economy, more legroom type of thing.
so they don't have a first class.
A lot of airlines are getting rid of first class. There was an article that, to this extent, there was an article that came out yesterday. Emirates is getting rid of first class on some of their A380s.
Oh, they're bringing the price down to business class.
So, a lot are just going away from it. Because the business class that's out there now is so much like what first class, you have your individual suites or your lie flats, your herringbones. Everyone has direct aisle access, which we'll see when we come up here just in this layout. It's no more, 2, 3, 2 in business and first. You don't have to crawl over people anymore the way that airlines are laying it out. So they're able to charge a premium for that, but not eat up so much space that they have to take out their economy area, and they can add that economy comfort. I'm flying to Canada tonight, basically, and it's on American, and I didn't get my business or first class upgrade, so I got upgraded to premium economy. So they're using that as a way to also enhance people's experience.
Same as comfort.
Yep, it's like premium, economy comfort on Delta, economy comfort on United. It's funny because my brother calls me up, and love my brother to death, really smart guy. He calls me, he's like, the planes on Boeing airplanes the seats on Boeing airplanes are so uncomfortable. I'm like, those aren't our seats. That's your airline choice, and that's one thing we always have to. Everybody in this industry has to make sure the customers understand that the airlines are choosing that. We designed this unbelievable architecture, and then they get to design this design within limits, how they're going to put their brand in this unbelievable airplane and utilize this. We have teams that work with them on that. We have our customer experience team. We have our Dreamliner gallery, all of that, so they can go out and they can see these things. But a lot of that is just driven by the customer. It's customer specific, customer choice. Yeah, it's
And that's set up to the airlines.
As Catherine said, Catherine mentioned, we have all that research that says everything plays into it. It's the cabin altitude, 6,000 feet. It's the more humidity in the airplane. It's the big windows. It's the big ceilings. It's the tucked away bins. It's unbelievable what just having that bin pushed back away so you can see across and you're not doing this, especially as a tall person, how much more open and how much more personal space you feel like you have. So, all right, let's move on up to the front part of this airplane. So you come into this flight deck. You've got 5 flat panel screens, 15-inch diagonal diameter. You have each pilot is going to have a PFD, right side on the FO side, left side on the captain side. You have your MFDs, and then your FMSs, your FMC screen down there. Multiple different functions. You can toggle through maps, checklists, approaches. One really cool thing is on the MFD, there's new technology out there called VSD, Vertical Situation Display. When you're flying into maybe mountainous airports, things like that, you can you have your approach on your PFD, you have it plugged into your FMS, you can put the terrain feature up on your MFD, but then you can also show where you are in relation to that terrain down on your vertical situation display. It's giving that second level, the third level of situational awareness. So all that's possible here, and we've actually been able to transfer that technology to other airplanes as well. You have your Class 3 EFBs, which we talked about earlier. You can do takeoff calculations, en route calculations. All that data transfers to your FMS. Your ACAR system separate from that. Furthermore, you have your 2 jump seats up here for your additional crew or your jump seat riders. high comfort flight deck seats. And then when you get into the flight deck, this is where Boeing's flight deck philosophy comes in. Pilot interface. We use the technology to help, to aid the pilots in safe and efficient operations. So if I'm the captain and we have a first officer and I pull back on my control column, first officer's control column is going to move back. He pushes forward or she pushes forward, mine's going to push forward. As the throttles move, as we've mentioned, as all the throttles kick in, you actually see the throttles move. We believe that is all helps with that situational awareness, helps the pilots understand what's happening, where it's going, and that if they need to do something, they're seeing what's just occurred and they can override that, rather than guessing what's occurring at the same time. So any questions up in this flight deck area? And also one other thing, you have your two HUDs, heads-up displays, standard on the 787. Helps with your low visibility and situational awareness.
These were Cat 3 airplanes out of the box, right?
Yes. So they're Cat 3 capable airplanes, but also the operator and the crew has to be Cat 3 qualified. Yep.
So this is the crew vest. This is because this is a long haul airplane. Sometimes they need to put more than one crew on board. This one has 2 berths for the pilots, and one, if you can see behind you, the seat, that seat is flight worthy, so that makes it so that pilots that are deadheading don't have to take up one of the seats in the back. They can actually sit in here.
So while we're right up here and we have quite a bit of space, talk about the windows. Awesome windows. So these are roughly 25% bigger than Airbus's newest competitor airplane, the A350. 78% bigger than previous generation airplanes. So that's 67, A330. So quite a lot bigger window. And I believe there's some mock-ups in the back to show the size difference.
Yeah, we've got them at different levels.
Yep. So, but you know, it's all part of that total experience. Here's my favorite part on airplanes, and for those who travel a lot or did travel a lot, one of the best parts about watching people get on an airplane is trying to figure out how to operate an overhead bin. And I believe, are these ones operational? Are these operational? Okay. So you can open it 4 ways. You can push, you can pull, you can push, you can pull. So no matter what somebody walks up and does, well, how does this work? Do I push it? Oh, well, yeah, I guess I push it. Next person comes up, well, do I pull it? I guess, yeah, I do pull it. So four-way, open it up. Also, place for everyone's bag. You can do 5 IATA standard size bags on their side, going across, and shove some jackets in there and a few other things if you need to. So that was a real big thing because, after mid 2000, 2005, 2008, everyone started really looking into, okay, do we charge for checked bags? Now you go on a flight, and what was a carry-on today, 10 years ago is a briefcase. Now you have people carrying steamer trunks as carry-ons, and it's just so when we designed this airplane, we really looked at the bin size, the ease of ability. Also, notice the loading height. You don't have to be extremely tall anymore to put it up there.
Yeah, the other thing I remember we can touch on is the mirror. For a lot of the folks who, you forget your cell phone, you can easily see what's in there. And it's really very, very, very ingenious for folks. There's a mirror right there so you can really see.
Or if you left a child.
Or if you left a child there, there you go.
I think my parents tried to do that a couple times when I was younger.
No center bins, they're all on the side.
Not on this business class area.
Back in the back there.
Yep.
You don't need them in this area.
Cruise. And you have cruise.
Because there's enough room for the number of seats that are
up
up
here.
here. There's enough room on the sides, so you leave it open. So this one, the only reason why it drops down is because it's
Crew rest. But notice as we go back, even with the center bins back there, you don't feel as if they're on top of you. So, all right. So as we go back, you're coming into your economy section. Get your center bins, but again, tucked up and away from you, so you're not hitting them with your head. Still high, same bins as up there. Same intuitive design here. Large windows. Again, as you walk through this, it just feels so open. I mean, like I said, I'm 6'2", and I still feel as if I'm walking through a big open space and not a metal tube.
Well, you have both headroom and shoulder.
You have headroom, you have shoulder room, you've got it all. And now we come down to our window dimming. So here's what I was talking about, where we show the comparative size to our competitor airplanes.
This is actually the size of an A330 window, so you can see how much bigger these are. And even the brand new one that they're getting ready to come out with, it is an all-composite airplane. Their windows are not as large as these windows are. So these windows are electrochromic windows, so they do not have physical shades that shut down, which is completely different. There's not another airplane in the industry that has this. So what happens is the customer can control how bright or how dark they want it to be. There's 5 different levels of it, and you can see it will gradually change. If I take it all the way down to dark, it usually takes it about a minute to get fully dark, and it will go at its darkest phase while you can still work on your computer or not disturb your neighbor. It will get dark enough, yet you will still be able to see outside.
So the flight attendants can control it, absolutely.
Can control
the dimmability. Yep, they can override that. So, if you're watching a movie or nighttime or people are sleeping for whatever reason, and rather than have to go through and lean, I'm sure we've all had that where they've come over and they've leaned across you and trying to shut your shades. They can now just do it all up there, and they can do it section by section.
Oh, they can.
Yep.
Okay.
Or individually?
Yep.
Oh, nice.
Are these the different levels here?
We're missing a couple. We're missing a couple here, but as Catherine said, you have fully transparent and 4 different levels of dimmability.
And maybe the other thing I want to touch on, like Catherine said earlier, is we look at passenger comfort. I mean, can you imagine? You look at the size of us, the size of the windows. You have somebody in the middle seat here, can easily see outside, which you don't see in the older airplanes or even the Airbus airplanes. So I think that's also a really big thing.
I'm
the aisle seat, you can't see outside.
I'm one of those crazy ones who always books a window seat. A lot of people book aisle seats for more comfort. I like the window seat because I like to look outside. But now I can sit in the middle seat and do it. So.
That's really huge too.
So this was what we called the dance floor area on this.
This section right here or the back? Right here.
Yep.
When we outfitted it for the Dreamliner, we left this space open to be able to use it
Tables.
for press briefings or meetings or special tours or readings. We did do that, and we actually set up a few displays inside of here as well. So we left it open. The question we usually get is, you call it the dance floor, did you actually dance here? And the answer is yes. We had everything from the first ones who danced in this section were we did a crew rest in Shannon, Ireland, and there were some youngsters who wanted to see the airplane. They came to the door to ask if they could come in, and they brought their hand harps and their flutes, and they played Irish music for us here and did Irish dance in this section. One of our pilots happened to know how to do Irish dance, so we had him dancing with the lot of them.
Oh, super.
We also had the Boston Minutemen in here. We had some dancers from one of the Asian countries in here as well. And then one of our demo flights in Kenya, while we were up in the air, because during the demo flights they were allowed to get up and move around, they were actually doing conga dance back here. So,
So a couple points to always keep in mind with this. This is always just an experimental airplane. It was the 3rd one built. Over 800 hours were logged on this plane during the flight test period. So this was never, correct me if I'm wrong, never intended to go to a customer.
Is that true of the first 3 or just this
Yes.
one? The first 3 were never intended.
Yes.
And I presume that's kind of normal with developing most new airplanes.
I haven't been around a brand new airplane program, so obviously the Dash 9 we had airline planes, as part of that flight test period.
747 over there, number
747,
one, that
yep.
was never intended
Never
for
intended.
passenger service. It was always a test airplane.
So
I think it depends on whether it's, so the difference is if it's a derivative airplane versus an all-new airplane. And this one was an all-new airplane, as was the 47.
Yep.
That's a question a lot of people are interested in, is
Yeah.
why you couldn't fix it up and sell it.
Was
It's
it
an interesting
800,
talking point.
800 hours flight test or 800 hours total? Including
800 total, 800, about 800 and I think 80 if I remember right.
What
Wow,
was
there you
this
go.
one used for mostly to test?
There's a whole
Anything?
list.
There's a whole list. It did environmental testing. We did the freezing, you know, where we drop it down to -30, -45. We did hot weather testing on it. It went through the gauntlet. This is one of the planes where we had to show all those extremes for that certification process.
The reason why this even has had a partial interior, of the 3 test airplanes that we're talking about, this is the only one that had an interior put in because it was the one that did all the testing for the interior stuff as well.
You know, all the stove bins are lockable.
They just locked them here.
Oh, okay.
Yep. This plane's been in service since October 2011. 25 customers. We have 270 routes actively being flown right now. Of those 270 routes, 39 are never before connected markets. 15% of the routes out there being flown by this airplane are markets that have never been connected. London to Austin, Denver to Narita, Narita to San Jose, San Francisco to Shanghai. Those are just a few examples of those. This plane is doing what we said it was going to do, and the customers are flocking to it. I tried to book myself on one. I couldn't get on one. I was looking a month out.
Well, this is one of those interesting phenomena when we put it back in the air after the grounding on it. United put theirs on local routes initially to ease it back into service. They had a situation where people were changing their flights off of other airplanes onto the 787.
And maybe one other thing I'd like to point out, I think Catherine you said it earlier, is end of the day, this airplane is supposed to make money for the airlines. And you look at the 20% fuel efficiency. That alone, yes, the passenger experience is great for the flying customer, but the folks who buy the airplane are really making a heck of a lot of money out of this airplane. So I mean, the bean counter, they're really seeing, the value of this airplane. Of the beans.
Excellent.
Can you tell us what the list price of the airplane is?
Boeing.com.
It's on the
I
website.
was trying to remember
I've
because
got
they
it,
just
Michael.
upped it.
They just upped it.
It just went up a little bit. That's the only reason why we can't pull it to you off the top of our head.
I have the data on my desk actually.
I
but-
actually I think it's in your deck too. But I'm not sure.
Yeah.
Once I've got it, Michael.
Yeah.
Is it true that 1 and 2 are likely to go to Pima and Narita?
We're not discussing the other placements right now.
That's just a guess then. Oh, one other thing. I understand they're producing 10 a month now. Is a final assembly done all at Everett, or do the final ones come out of Charleston also?
Final come out of Charleston as well. Yep.
What percentage?
We don't do the split. It's 10 a month it's 10 a month in the program.
It just varies by what's coming down the
Yep.
pike.
Fantastic presentation.
Yes, thank you
Thank
very
you
much.
very much.